The next question is, consider the deformable pin jointed truss with loading geometry and section properties as shown in figure. Given E, A, L and P equal to 1 kN. The horizontal displacement of joint C in mm is. Now we have to determine the horizontal displacement of joint C. So we will apply virtual work method and we will solve this truss for two cases, one for the actual loading and one for the unit load, virtual load, that is 1. So let us solve. For the first case we will apply the actual loads given. So it is P and 2P, and P it is given to us 1 kilonewton. So here this is 1 and here 2P, that is 2. This is only vertical reaction here, both vertical and horizontal. So let this be R1, this R2 and this R3. Now applying summation fx equal to 0, R3 will be equal to 1. Taking moment about this point equal to 0. So the moment of this force will be R1 into L, this distance is L, and moment of this force will be 1 into L. Now about this point, moment of 1 is in clockwise direction. So moment of this R1 should be in anti-clockwise direction. It implies that this R1 into L plus 1 into L equal to 0. So from here we are getting R1 equal to minus 1. Since R1 is minus 1 and R2 is in vertical upward direction and this is vertical load in downward direction, that is 2. So applying summation Fy equal to 0, we will get R1 plus R2 equal to 2. R1 is minus 1 plus R2 equal to 2, which implies R2 equal to 3. So this is 1 downward R1, R2 is 3 upward, this is 1 and this is 2. So solving the member forces, let assume this member be A, this member B and this member C. So at joint B, let us draw here, this is joint B. From here it is R3 force which is equal to 1. From bottom it is R2 force which is 3. From left let it be FAB and from top FBC. So here FAB will be equal to minus 1, FBC will be equal to minus 3. This is a simple application of method of joint. And to determine FAC, we can use joint A. So at joint A, from bottom there is R1 and here it is FAB. Now since FAB is minus 1, so we can directly apply it to be 1. And here FAC. Now since this is L, this is L, so this angle is 45 degree. So FAC by root 2 will be equal to 1. So we can safely calculate FAC as root 2. Now let us solve the second case, that is applying unit load. So again this is our pin jointed truss. This is A, B, C. Here R1, here R2, here R3. Now we have to determine the horizontal displacement at joint C. So we will apply a unit load along the horizontal direction. Now again applying the equations of equilibrium, summation fx equal to 0. From this we will get R3 equal to 1. Taking moment about B equal to 0. So this force is 1, this lever arm is L. So 1 into L, this force is R1 and lever arm is L. This will be equal to 0. From here we are getting R1 equal to minus 1. And again applying summation Fy equal to 0. So R1 plus R2, this will be equal to 0. So here R2 will be equal to plus 1. So R3 1, R1 minus 1, R2 1. So this is minus 1 downward, this is 1 upward, and this is 1. Analyzing the truss, again at a joint B, from here it is unit force, from bottom it is 1, here FAB, here FBC. So FAB will be equal to minus 1, FBC will also be equal to minus 1, and FAC can be calculated at joint A. So at joint A, R1 is downward 1, FAB minus 1, so it is compressive, this is 1, and this is FAC. So it is same figure, this is also 45. So from this we can calculate FAC equal to root 2. So finalizing the values. So plotting the values, member AB, BC and AC. The force due to actual load we denote it by P. The force due to unit load we denote it by K, L and AE. Now force due to actual load in AB member is FAB minus 1. So this is minus 1. In BC minus 3. So it is minus 3. And in AC it is FAC is root 2. So this is root 2. Now force due to unit load, FAB minus 1, BC minus 1 and root 2. So minus 1 and root 2. Length of the members AB and BC, L and L, 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 and member AC, it is root 2L. So it is root 2L. AE, so the values are for AB AE, for BC AE and for AC 2A. So AE, AE and 2A. And according to virtual load we have to find out summation PKL by AE. So for AB it comes out to be minus 1 into L by AE. So it is L by AE. For BC, minus 3 into minus 1, that is 3. So it is 3L by AE. And for AC, root 2 by 2. So 2 root 2 by 2. So it comes out to be root 2L by AE. So summation will be equal to L by E into 1 plus 3 plus root 2. So this is 4 plus root 2, that is 5.414 L by AE. So our horizontal deflection delta at C will be equal to 5.414 into L by A into A. Putting the values 5.414. Since the unit load given to us is 1 kilonewton, P given 1 kilonewton. So we should write the value of modulus of velocity in kilonewton per meter square. So E is 2 into 10 to the power 11 Newton per meter square, that is 2 into 10 to the power 8 kilonewton per meter square. So E will be 2 into 10 to the power 8 kilonewton per meter square. L is given to us 1 meter. So this is 1 meter, and cross section area is given to us 10 mm square. So it is 10 mm square. This is mm, and also it is 1 kilonewton of load. Now kilonewton will cancel out, but here it is meter square and mm square. So we should write either these values in mm square or this in meter square. So let us convert this mm square into meter square. So 5.414 into 1 meter, kilonewton get cancelled out. This is 10 into 10 to the power minus 6 meter square into 2 into 10 to the power 8 by meter square. So meter square gets cancelled out. We will get answer in meters. So this comes out to be 5.414 divided by 10E6 divided by 2E8. So 2.7075 into 10 to the power minus 3 meters. We have to determine the answer in mm up to 1 decimal places. So it will be equal to 2.7 mm. So correct answer will be this option. The next question is, rainfall depth over a watershed is monitored through 6 number of well distributed rain gauges. Gauge data are given below. So rain gauge number, rainfall depth in area of Thyssen polygon. The Thyssen mean value in mm up to 1 decimal places of the rainfall is. So it is a direct question. We know that the mean value of rainfall is given by summation of rainfall at ith station into representative area of ith station divided by summation of all the representative area. So putting the values P1A1 plus P2A2 and so on. So 470 into 95 plus 465 into 100 plus 435 into 98 plus 525 into 80 plus 480 into 85 plus 510 into 92. This whole divided by summation of area, that is 470 plus, this is rainfall, area is this 95 plus 100 plus 98 plus 80 plus 85 plus 92. We are not writing this value because it appears in both numerator and denominator and they will get cancelled out. So solving this, we will get annual rainfall equal to 479.09 mm. So this would be our answer. So up to 1 decimal places, that is 479.1. The next question is, the infiltration rate F in a basin under ponding condition is given by F equal to 30 plus 10 e to the power minus 2t, where F is in mm per hour and t is time in hour. Total depth of infiltration in mm up to 1 decimal place during the last 20 minutes of a storm of 30-minute duration is. So the variation of rate of filtration is given to us 30 plus 10 e to the power minus 2t mm per hour, where here this time is also in hours. We have to find the total depth of infiltration for the last 20 minutes of a 30 minutes duration of storm. So we have to find out total depth of infiltration from 10 minutes to 30 minutes. In terms of hour, it will be 10 by 60 hour, that is 1 by 6 hour, to 30 by 60, that is 1 by 2 hour. Now the depth of infiltration is given by integral f dt, and the time limits will be 1 by 6 to 1 by 2, 1 by 6 to 1 by 2. Putting the values, we will get 1 by 6 to 1 by 2. F is 30 plus 10 e to the power minus 2t dt. So integrating, we will get 30t minus 10 by 2 e to the power minus 2t, 1 by 6 to 1 by 2. So putting the values, we will get this equal to 11.74 mm. So the correct answer would be 11.74. The next question is, a rigid smooth retaining wall of height 7 meter with vertical backfill retains saturated clay as backfill. The saturated unit weight and undrained cohesion of the backfill are 17.2 kN per meter cube and 20 kPa respectively. The difference in the active lateral forces on the wall in kilonewton per meter length of wall up to 2 decimal places before and after the occurrence of tension crack is. First of all, the depth of tension crack is given by h equal to 2c by gamma root Ka. Now active earth pressure is given by 1 minus sin phi by 1 plus sin phi. Since it is given to us, the soil is K and for clay phi is 0. So Kaa will be equal to 1. So depth of tension crack will be equal to 2 into C, that is undrained cohesion 17.2. Sorry, undrained cohesion is 20. So 2 into 20 by gamma is 17.2 into root K, that is root of 1. So it comes out to be 40 by 17.2, that is 2.326 meter. Now coming to the arrangement, the height is 7 meter. So this is total 7 meter and that is retained by backfill. There are two cases we have to consider before and after the occurrence of tension crack. So before the occurrence of tension crack, the variation of earth pressure will be like, let us draw again. This total depth is 7 meter and variation of earth pressure before development of tension crack. So we know that the variation of earth pressure is given by sigma equal to Ka gamma d minus 2c root K. Now at the top depth is 0, so the value will be minus 2c root K, that is minus 2c. And at the bottom the value will be Ka into gamma and d will be 7. So Ka gamma into 7 minus 2c root K, so 2 into c. So this value will be equal to minus 2c, that is 40, and we have drawn on the left side, so sign is accounted, and this value will be Ka1 1 into 17.2 into 7 minus 40. So 17.2 into 7 minus 40, it is 80.4. So this will be the distribution of earth pressure before development of tension crack. Now once the tension crack gets developed, the contact of soil and retaining wall will not be there. So up to this height there will be no contact and hence no development of earth pressure. So the earth pressure will get developed only in this much portion, and this value is 80.4. Now we have calculated h is 2.326, so this much distance is 2.326. So we have to determine this much area and this area. So for this case, force will be equal to area of this triangle minus area of this triangle. So it will be, since it is 7 meter, this value will be 7 minus 2.326 meter. So this is 7 minus 2.326, that is 4.674, and this is also 4.674. So this F1 will be equal to this minus this. So half of base, that is 80.4, into height 4.674, minus half of base is 40, into height is 2.326. So it comes out to be 0.5 into 80.4 into 4.674 minus 20 into 2.326. So this is 141.375, and for this case F2 will be equal to half of base is 80.4 and height is 4.674. So this is equal to 187.895. So the difference in the values will be 187.895 minus 141.375. So it comes out to be 46.52. This will be our answer. The next question is, an aircraft approaches the threshold of a runway strip at a speed of 200 km per hour. The pilot decelerates the aircraft at a rate of 1.697 meter per second square and takes 18 seconds to exit the runway strip. If the deceleration after exiting the runway is 1 meter per second square, then the distance in meter up to 1 decimal place of the gate position from the location of exit on the runway is. So the situation is like this. Suppose this is our runway and aircraft approaches the threshold. This is our threshold point. At this point the velocity of the speed of aircraft is 200 km per hour, and on the runway the aircraft decelerates, that is negative acceleration of minus 1.697 meter per second square, and the time required is 18 seconds. So in 18 seconds it reach up to the exit point, but after exiting there is some speed and the acceleration rate is negative minus 1 meter per second square, and after that it reaches the gate position. Now here speed is given to us, and we also know that at the gate position the speed will be equal to 0. So let it be v1 and let it be v3, and assume the speed at the exit point be v2, and we have to determine the distance of gate position from the location of exit. So this is our distance we have to calculate. So we can calculate it by applying the kinematic equation. So firstly we know that v is equal to u plus at. Applying for this runway position, v will be equal to v2, u will be equal to v1, a will be equal to minus 1.697 meter per second square, and t will be equal to 18 seconds. So this equal to v1 is 200 km per hour. So 200 km per hour, this is equal to 200 into 5 by 18 meter per second minus 1.697 into 18. So V2 comes out to be 200 into 5 by 18 minus 1.697 into 18. So this is equal to 25 meter per second. Now for this case we will determine the distance. So we'll apply V square equal to U square plus 2AD. For this case the final velocity V3 is 0, initial velocity is V2, so V2 square plus 2 into A is minus 1 and D we have to calculate. So from here D will be equal to V square by V2 square by 2. So that is 25 square by 2. So it comes out to be 625 by 2, that is 312.5 meter. So the correct answer will be 312.5. The next question is a 0.5 meter into 0.5 meter square concrete pile is to be driven in a homogeneous clay soil having undrained shear strength Cu equal to 50 kPa and unit weight gamma equal to 18 kN per meter cube. The design capacity of the pile is 500 kN. The adhesion factor alpha is given 0.75 and the length of the pile required for the above design load with factor of safety of 2.0 is to be calculated. So it is 0.5 by 0.5 concrete pile and we have to determine the length of the pile. Now we know that the design capacity of pile is given by QB into AB plus QF into AF. This is the contribution from bearing and this is from friction. Now QB is equal to C into NC and AB will be equal to area, and this is given to us 0.5 and this is also 0.5. So this will be equal to 0.5 square plus QF. QF will be equal to adhesion factor alpha into C and AF will be the surface area of the pile. So surface area of pile will be equal to perimeter into length. So perimeter will be 0.5 plus 0.5 plus 0.5 plus 0.5. So this will be equal to 4 into 0.5 into length. Now the capacity is given to us 500 kilonewton. So this is 500 equal to C is 50 and we know that for clay soil NC is 9. So it is 0.5 square plus alpha given to us 0.75 C 50 and this is 4 into 0.5 into L. So solving this we will get L equal to 500 minus 50 into 9 into 0.5 square divided by 0.75 42. But factor of safety is also given to us, so we have to include it. So design capacity will be this value divided by 2. So we should divide whole this value by 2. So from here we will get L equal to 500 into 2, that is 1000 minus 50 into 9 into 0.5 square whole divided by 0.75 into 50 into 4 into 0.5. So it comes out to be 11.83 meters. The next question is an RCC beam of rectangular cross section has factored shear of 200 kilonewton at its critical section. Its width B is 250 mm and effective depth B is 350 mm. Assume design shear strength tau C of concrete as 0.60 Newton per mm square and maximum allowable shear stress tau c max in concrete as 2.8 Newton per mm square. If two legged 10 mm diameter vertical stirrups of Fe 250 grade steel are used, then the required spacing in centimeter as per limit state method will be. Now the shear strength is given to us tau c equal to 0.62 and we have to determine the spacing. So for defining spacing we should first find out the nominal shear stress generating. Nominal shear stress will be given by design shear force divided by BD. Now the design shear force, that is factor shear force, is 200 kilonewton. So 200 into 10 to the power 3 Newton divided by B is 250 and depth is 350. So 250 into 350 mm square. So it comes out to be 200 E6 by 250 by 50. So 2.2857 Newton per mm square. Now the design shear force is given by VUS equal to tau V minus tau C into BD. So this will be equal to tau V is 2.2857 minus tau C is 0.62 into BD 250 into 350. So it comes out to be 145.748 kilonewton. Now the spacing is given by 0.87 Fy ASVD by VUS. So putting the values, 0.87 Fy, it is given to us Fe 250. So 250 into ASV, area is two-legged 10 mm diameter vertical stirrup. So AS will be equal to 2 into pi by 4 into 10 square. D is 350 whole divided by VUS, that is 145, and since we have written 250 Newton per mm square, so we should write it in newtons. So 145.748 Newton. So this comes out to be 82 mm. We have to solve it in centimeter, so it will be 8.2 centimeter. So the correct answer would be 8.2. The next question is, a priority intersection has a single lane one-way traffic road crossing an undivided two-lane two-way traffic road. The traffic stream speed on the single lane road is 20 km per hour and the speed on the two-lane road is 50 km per hour. So there is an intersection at which one single lane road and another two-lane road is intersecting. The speed at single lane road is 20 and the speed at two-lane road is 50. The perception reaction time is 2.5 seconds, coefficient of longitudinal friction 0.38 and acceleration due to gravity 9.81. A clear sight triangle has to be ensured at this intersection. The minimum lengths of the sides of the sight triangle along the two-lane road and the single lane road respectively will be. So it is a direct question. Let this distance be D1, this distance be D2. The stopping sight distance for single lane D1 will be equal to the distance traveled during reaction time V1t plus distance traveled during braking, that is V square by 2gf. Now V1 is given to us 20 km per hour, so this will be equal to 20 into 5 by 18 meter per second. So it is 100 by 18, that is 5.55 meter per second. Similarly, V2 will be equal to 50 into 5 by 18, that is 13.89 meter per second. So D1 will be equal to V1 5.55, reaction time is 2.5 second plus 5.55 square by 2 into 9.81 into friction coefficient is 0.38. So this comes out to be 18 meter, and D2 is V2t plus V2 square by 2gf. So this will be equal to V2 is 13.89, reaction time is same 2.5 seconds plus 13.89 square by 2 into 9.81 into 0.38. So it comes out to be 60.6 meter. So the correct answer will be this and this, that is B option.